All right, here we're going to have lesson 3 on speed and velocity, focusing on our learning targets to be able to calculate change in time and change in distance, and be able to calculate velocity of an object using the formula. When we talk about time, we're talking about when objects move through space, they're also moving through time, which is going to be abbreviated by the letter T. Time only has one direction, which is forward. We've talked about that. You cannot go backwards in time. It can be measured in seconds, minutes, or in hours, and those are the abbreviations that we'll be using to represent those. If we're going to calculate time, how much time has passed, we're finding a difference in time from the second time minus the initial time to give us the change in time, also known as delta t. When we have speed, the symbol for speed is v. It's a scalar quantity that's going to describe how far an object travels in a given time. So an example is 10 kilometers per hour. It's measured, could be also measured in meters per second or kilometers per hour. The calculation that we're going to use for that is using this formula here. So we have speed is equal to the change in time, the change in position divided by the change in time, where speed is equal to v and distance is equal to d. Note you're going to have to solve for all 3 variables depending on what the question is asking. We're going to go through a couple examples together to discuss what that could look like. Example 1. Duncan is fashionably late for science class and moves 15 meters in 30 seconds. What is the speed of Duncan? So using our formula, v is equal to the change in position over the change in time. He changed position of 15 meters divided by 30 seconds to give us 0.5 meters per second. So that was Duncan's speed arriving to science class. Here we have an example of a slug. It moved 10 meters in 30 minutes. What is the speed of the slug? Now notice in this example, it has minutes compared to seconds. So we could solve for it 2 ways. We could have 10 meters divided by 30 minutes will give us 0.33 meters per minute. The question doesn't tell us specifically how it wants the answer. It could, and therefore we could also use a second way. I'm just writing the formula here. We could convert 30 minutes into seconds. So to convert minutes to seconds, we need to multiply by 60. So the change in time is equal to 30 minutes, which is also equal to 1800 seconds. So another way we could calculate it, speed is equal to the change in position over the change in time. The change in position is 10 meters divided by 1800 seconds to give us 0.0056 meters per second. So those are 2 ways that we could see that question. Depending on what it asks us, that may vary. This one it didn't, so I provided both. Here we have velocity. Notice the symbol for velocity is a V with the arrow on top, indicating that it's a vector quantity and that it measures the displacement of an object over a given time. 2 meters per second north is an example. Notice how it gives the direction, so that's how we know it's a velocity. Could be measured in meters per second or kilometers per hour, and we're going to use the following equation. So we have velocity is equal to the change in displacement over the change in time. You can solve for the change in displacement taking position 2 minus position 1 and taking time 2 minus time 1 to find the change. Here we have an example of how we're going to calculate velocity. Mimi walks 3 kilometers east to Massey in half an hour or 0.5 of an hour. What is Mimi's velocity? So we're going to start off with our formula, change in displacement over the change in time. So the velocity is equal to 3 kilometers and in this case east, over 0.5 of an hour. So 3 divided by 0.5, the velocity is equal to 6 kilometers per hour. Note the direction is east. In this example, example 2, a truck is traveling north down Pembina Highway at 60 kilometers per hour. So when I see 60 kilometers per hour, I'm taking note that that is giving me the velocity. It has a distance and a time. So what is a truck's displacement in 15 minutes? So if I have my formula, velocity is equal to the change in displacement over the change in time. Velocity is equal to 60 kilometers per hour, and that was north. Time was equal to 15 minutes, which is equal to 0.25 of an hour. So we are trying to solve for displacement. I'm going to substitute my value of velocity and the value of time into the formula. So I have 60 kilometers per hour is equal to the change in displacement, what I'm going to solve for, divided by the change in time, which is, I'm going to use 0.25 of an hour. I need to get the change in displacement on its own, so I'm going to multiply 60 times 0.25 to give us 15 kilometers. So the displacement is equal to 15 kilometers. Here we have types of speed and velocity. You may see them come up in a question. You can reference back to these types of speed and velocity, recognizing that the only difference between speed and velocity is that velocity has a direction. So you could have constant or uniform speed or velocity. That's when an object is traveling at the same speed over a period of time. Instantaneous speed or velocity is a measurement of how fast an object is moving at a precise moment. So the speedometer on a car gives a reading of the instantaneous speed of the vehicle. The initial speed or velocity is how fast an object is moving at the beginning of a scenario, and that's often represented by V1. And the final speed is at the end of a scenario, which is represented by V2. If an object changes speed, the average can be determined by this formula here. You will notice that it is the same, except it's represented by AVG. So we have average velocity. I'd like you to take a moment to summarize 2 things that you've learned from this lesson on speed and velocity. It could be the formulas, it could be the difference between speed and velocity, but take a moment to summarize what you've learned before moving on to the practice sheet.